All right, so in 6.3, which we started yesterday, we talked about component form and magnitude and then all the properties of vectors, what you can do with it. And then we talked about linear form, which is like number 5, where you've got the ij going involved. So for a component form and magnitude, and I should have labeled them. You would have given them labeled as initial or terminal, or in the homework you were given some that had a graph. Remember, the arrow points towards the terminal, okay, or away from the initial. So if that's the case, then for component form, I would do the second x, which in this case is -8, minus the first x, which is 1, and then the second y, which is -9, minus the first y, which is 3. So the component form here would be -9 and -12. And remember, it goes in those little brackets because that's not a coordinate point. That's a change in x and a change in y. Maria?
What would have happened if you called -8, -9 initial and then 1, 3 terminal?
Your signs would have been opposite.
And would it still be proportional to the direction?
Yeah, but if you had actually graphed it, it wouldn't have. Your arrow would be going in the wrong direction. Does that make sense? So you'll be told which one's initial, which one's terminal, or you'll get a graph in which the arrow points towards the terminal. Yeah. All right, so then B is the magnitude of this. So remember, when you have the initial and the terminal, you have two choices. One is the distance formula, and the other is the square root of a squared plus b squared. So I'm going to use that here. If I didn't have the initial and the terminal, I only had the component form, then you'd have to use the square root of a squared plus b squared. So for this one, I'd get the square root of 9 squared, which is 81, the square root of 12 squared, which is 144, and I get the square root of 225, which is 15. And that's the magnitude or the length of this. Questions so far? So if you wanted to check this, you could simply plot that on a coordinate grid and count your x difference and your y difference, and that should be your A. And then you can kind of estimate your length, or even use a right triangle, because that's what you're forming with a change of x and a change of y. And you would be able to get your magnitude. All right, numbers 2, 3, and 4 are based on u being -5, 3, and v being 0, 0. So if it's u plus v, then I'm adding the first term in each. -5 plus 0 should be -5, and I'm adding the second term in each, 3 plus 0, which would be 3. U minus v is taking the first one in u and subtracting the first one in v, so it still doesn't change because it's 0, but it would be -5 minus 0. And then 3 minus 0, again, would stay 3. For number 4, you've got to change, so it's called a scalar, right? Multiple, where you would multiply 2 times the u, so 2 times -5, 3 is -10, 6. Minus 3 times the v, which would be 0, 0. Or you could distribute a -3, it doesn't matter, and then add, same thing. And now I'm going to subtract. So first minus first, -10, and second minus second, which is 6. Question on any of those? All right, so then 5 started the linear format. So remember that linear and component form, initial component form, are interchangeable. So if the linear throws you, because a lot of you got stuck on the homework on a couple of questions, it was just that it asked you to find it and then put it in linear format. I forget what numbers they are, but I'll go back to it. So you have two options here. One is take this and put it into your initial format, which would be -3, 4, and 2, -1. Or, and I think it's easier in this case, use it as though it's variables. So 2 times u would be 2 times -3i plus 4j plus v plus 2i minus j. Distribute the 2, so it's -6i plus 8j plus 2i minus j. And then combine your like terms. So the 2 i's would get combined and the 2 j's would get combined. So I get -4i plus 7j. And remember that if it gives it to you in terms of ij, you want the answer to be back in terms of I and j. If it gave it to you in regular component form, you would want it back in regular component form. Questions on any of that stuff? Because then we're going to go through and finish what we needed to finish from yesterday. Okay. All right, so we're going to finish out 6.3, which was vectors or introduction into vectors, and we left off with unit vector in the same direction. If you watched the video from yesterday, this was on there, but I'm going to go back over it again because we didn't teach it live in class. So if you wanted to find a vector that goes in the same direction as the one you're given, then you would simply do the component form of that vector, which is what v is, over the magnitude of that vector. So what this is going to do is find another vector that would be going in the same direction, okay, but is going to have different lengths. So it's going to have a different magnitude. You don't want the same vector, but you want something that's going in the same direction. So it'll say find the unit vector in the same direction as the given vector and then verify the result has a magnitude of 1. So if the magnitude is 1 of what you get, then you know you're doing this correctly. So we're going to do the first one, which is in your initial format. So this is u. To find a vector in the same direction, or a unit vector in the same direction, I do the magnitude of u, I do the component form of u over the magnitude of u. So I already know the component form. That's what's given to me. That's 1, negative 3. What I have to find is the magnitude. How do I find magnitude? Good. So this would be 1 squared plus negative 3 squared, square root of 1 plus 9, which is the square root of 10. So that goes in the denominator. Now there's two problems with this. One is what? Can't have a root and a bottom. Good. The other thing is that's not component form. So I have to split it and rationalize it. Does that make sense? Yeah. So I'll show you two different ways. One is literally just split it. So it would be 1 over root 10 and then negative 3 over root 10. And then rationalize it. So I'd multiply both the top and the bottom by root 10. I get root 10 over 10. That's a root 10 over 10. And negative 3 root 10 over 10. So you can either split it and then rationalize it, or you can rationalize it and then split it. The order does not matter how you do that. So if I were to do that, root 10 would become, or 1 over root 10 would be root 10 over 10, and then I'd multiply that in as though it's the scalar times 1, negative 3. Either way, I'd get root 10 over 10 and negative root 10 over 10. So that's a unit vector in the same direction. And then it said to check it, show that the magnitude of that vector is 1. So if I go back to before I rationalize it, because it's going to be easier to do it from there, and I do the square root of a, which is 1 over root 10 squared, plus b, which is negative 3 over root 10 squared, I end up with the square root of 1 over 10 plus 9 over 10, which is the square root of 10 over 10, the square root of 1, which is 1. So that's how you can check your answer, okay? Your resultant vector should have a magnitude of 1. But this is really what you're looking for. Questions so far? Okay, so then B, I'm going to start the same way, except this time this is not in component form. So negative 3i minus 4j becomes what? In component form. Negative 3, negative 4. And be careful, there's one in the homework that the I and the j are switched. Whatever's in front of the I goes first, whatever's in front of the j goes last, no matter what the order is, okay? So now that's my component form. I would put this over the square root of negative 3 squared plus negative 4 squared. Square root of 9 plus 16 is the square root of 25, and the square root of 25 is 5. So this would be negative 3 over 5 and negative 4 over 5. This time I didn't need to rationalize. And then again, if I wanted to check, I would say the square root of negative 3/5 squared plus negative 4/5 squared, and I'd get the square root of 9/25 plus 16/25, 25 over 25, which is 1. Square root of 1 is 1. Monica. Yeah. Oh, good point. So because it gave it to you in ij, you want to put it back in ij, which would be negative 3/5 I plus, or sorry, minus 4/5 j. So again, whatever the question gives it to you in, you want to put it back into that format. Question so far? So in the homework, there's ones in which it says find the unit or find the vector in the same direction, but it gives you a magnitude. So what's happening is you're going to start the same way. So let's say it said that, but then it said the magnitude of the vector, of the new vector, is 4. All I do is take and use that as a scalar at the end. So I would do the same process until I get to, God bless you, until I get to my unit vector. But then at the end, multiply both the I and the j, or both the change in x and the change in the y, by whatever the magnitude that's given to me. So one of them's like 3. You got to take the 3, you got to multiply it times both of them. Okay, that's the only difference. So not only are you finding it in the same direction, but you're also elongating it by tripling it in this, or quadrupling it in this case.
The answer
Is this one?
Okay.
Yeah, in the IJ format. Questions? Okay. So then this one says, let V be a vector from initial point P1, -2, -2 to terminal point 2, P2, 2, 3. Write V in terms of I and J. So the first thing I got to do is figure out what V is. How do I do that? Component form. I have an initial and I have a terminal, right? Yes? Everybody see that? Yeah. So I would do 2 minus a -2, which becomes +2, and 3 minus a -2, which becomes +2. And I get 4 or 5. It said write V in terms of I and J, which means this is what? Good. 4I plus 5J. This is the first time I give you a graph with an initial and a terminal that we're not starting at 0, 0. That's why I did it. So if that's the case, you want to actually plot your initial point, which would be -2, -2, and your terminal point, which would be 2, 3. Draw your line, so it's a segment, and the arrow goes in which direction? Towards P2, right? Towards your terminal point. Along that line, it doesn't matter where you put your arrow, but the arrow has to point towards your terminal point, which would be P2. Now, if I were to count from one to the other, there should be a change in x of 4 and a change in y of 5. 1, 2, 3, 4, there's my change in x. 1, 2, 3, 4, 5, there's my change in y. So everything you map out without your graph, what should be confirmed by it if you were to graph it? It's like slope. Yeah, just that it's separated by a comma instead of a ratio. Everybody good? Yes? All right, writing a vector in terms of its magnitude and direction. So this time we're working back, well, kind of backwards. You're given the magnitude and you're given the angle that vector forms with the x-axis. And it's asking you for the component form. So again, you'll get given two things: the magnitude of the vector, the length of the vector, and the angle it forms with the x-axis. That's what your theta will be. So you would take and multiply the magnitude times the cosine of that angle. That's going to give you your change in x. So sometimes it goes in front of I, sometimes it would go by itself, depending on how it wants it. And then the magnitude times the sine of that angle, and that would go in front of j if it wants it in terms of I and j, or just by itself in this after the comma if it doesn't. So hopefully this makes sense, because think about your unit circle, right? Your points around your unit circle. If I gave you an x and y coordinate, which coordinate would you use for cosine? The x. And which one would you use for sine? Y. So that's why we find the cosine of theta to get the x coordinate, and we use the sine of theta to get the y coordinate. Okay? So you'll see these in two different ways. One, unit circle special angles in which you wouldn't use a calculator, and then other angles where you'd have to use a calculator. So your homework has one of each. If it is a special angle, don't use your calculator. Keep it exact. If it's an angle that's not on your unit circle, then use your calculator. Okay? There's one of each. So this is find the component form of V, given its magnitude and the angle it makes with the positive x-axis, and then sketch the vector. So here's my magnitude, and here's my theta. So it's going to be the magnitude of V times the cosine of theta, and the magnitude of V times the sine of theta. So 2 root 3 cosine 45, 2 root 3 sine of 45. What's the point at 45? It's been a long time since we talked about unit circle, right? It doesn't go away. Point there is root 2 over 2. And root 2 over 2. So this would be 2 root 3 times root 2 over 2, comma, 2 root 3 times root 2 over 2. And then you just want to simplify it. So the 2's would cancel. Root 3 times root 2 is root 6. Root 2 and 2 and 2 cancel. Root 3 times root 2 is root 6. Okay, so then it said to graph it. All right, so if I think about what's happening here, if I were to graph this vector, root 6 is obviously not a whole number, but it would be approximately what? It's in between what two perfect squares? It would be in between 4 and 9 or 2 and 3, right, once we square root it. So let's just say this is 2.5 because we're not going to get more exact than that, right? So let's say this is 2.5 and 2.5. Then when I graph it on a coordinate grid, try to graph it accurately, I'd go over 2.5 and up 2.5. And there's my vector. Now, does that appear to be about 45 degrees? Yeah, right? That makes sense? And if I actually measured this with, like, let's say you had a ruler, it should be 2 root 3. If we treated root 3 like 1.4, maybe something like that. So it'll be like 2.8-ish, okay? But they should be consistent with what you know about your coordinate grid. You're welcome. Questions on that one? So again, if it wasn't a special a special angle, then you would use a calculator. If it is, you need to use your unit circle. All right, last one from 6.3. So this says find the component form of the sum of u and v with direction angles theta u and theta v. And then I gave you the hint. Find the component form separately and then add the two vectors. So the result should be u plus v, but the first thing you have to find is what u is, and then you have to find what v is using what we just used, and then add them at the end. So figure out what the component form of u is, figure out what the component form of v is, and then add them together at the end. All right, so we were given all the individual parts, right? The magnitude of u, which is 5, times the cosine of theta v, or theta u, which in this case is 0 degrees. And then 5 again times the sine of 0 degrees. So at 0 degrees, what's your coordinate point there? What's the x? 1, and the y is 0. So this would be 5 times 1, and then 5 times 0. So I'd get 5, 0 as the component form of u. And then I want to repeat that whole process, but this time with v. The length is the same. It's 5. The cosine is now of 90 degrees. And then the sine at 90 degrees. So the coordinate point at 90, 0, 1, right? 5 times 0, and then 5 times 1. So it's 0, 5, component form of v. So if it just asked what they were, I'd be done. But at the end, it said to do what with these? Add them. So remember, I add, so u plus v. I add the first term in each. 5 plus 0 is 5. And add the second term in each. 0 plus 5 is 5. If I had drawn these out on my actual coordinate grid, it said it was 5 and it was at 0 degrees. So I'd go from here, 1, 2, 3, 4, 5. That would be u. And then v was 5, but it was at 90 degrees. 1, 2, 3, 4, 5. It'd be here, 90 degrees. And then if I added them, 5 and 5, my vector would be here. So the adding kind of splits the difference between the two. Questions on 6.3? Okay.